In this video, we're talking about how to solve a system of equations where we have three equations in terms of three variables. So we have three equations, 1, 2, 3, and x, y, z, three variables. Now, in a system of equations like this one, there are oftentimes many ways to go about solving for the solution to the system. We just need to look for one way to do it, and hopefully it'll be somewhat of an easy way. One thing that jumps out to us right away is that this first equation, if we look at the z variable, we have a plus 1z here. In the second equation, we have a minus 1z, so we know that if we add these first two equations together, we'll get plus 1z, minus 1z. Those two will cancel with one another and become 0, leaving us with just x and y. So let's go ahead and try that first. If we look at these first two equations here, we'll add them together and we'll get x plus 2x is 3x. We'll get 2y plus a negative y, or 2y minus y is going to be 1y, so plus y, plus 1z minus 1z, that's going to be 0. Those two will cancel with one another. And then 4 plus 0 is just going to be equal to 4. Now remember that when you're solving systems of equations, you're always going to need at least as many equations as you have constants or variables in order to be able to solve for the value of those constants. So the reason we know we can solve this system is because we have three variables, but we have three equations. We have an equal number of equations, so we should be able to solve for x, y, and z. We've combined these first two equations to get an equation in terms of two variables, x and y. We're going to need another equation in terms of x and y if we want to be able to solve for those values. Well, the way that we can get it is we can take, instead of the first and second equations, we can take the second and third equations here and add those together, because this second one has a negative z and the third one has a positive z. So if we add those together, we'll get z to cancel, leaving us with just x and y, and we should be able to use that in combination with this first equation in terms of x and y to solve for values of those two constants. So when we add these together, 2x plus 2x is going to give us 4x. Negative y plus a negative 2y, or negative y minus 2y, is going to give us a negative 3y. Negative z plus z is going to give us 0. Those two will cancel. And then 0 plus 1 gives us 1. Now we've simplified this from a system of three equations in terms of three variables to a system of two equations in terms of two variables. So we've essentially eliminated a variable, and now we should be able to use this system to solve for x or y. Notice here that we have a plus 1y in our first equation and we have a minus 3y in our second equation. If we multiply this first equation by 3 such that we end up with positive 3y, then we could add the two equations together to get the y's to cancel, and we'd be able to solve for x. So in order to do that, we have to multiply this first equation by 3, and now this becomes a distributive property problem where we distribute the 3 across every term from the left and right hand side in this equation. So this then becomes 3 times 3x gives us 9x, 3 times y gives us plus 3y, and 3 times 4 gives us 12. So we have 12 here. And then we're going to have 4x minus 3y is equal to 1. Now when we add these two equations together, like so, we'll get 9x plus 4x is 13x, 3y plus a negative 3y, or 3y minus 3y, gives us 0, those cancel, and then 12 plus 1 gives us 13, so we have 13x is equal to 13. Dividing both sides by 13 gets 13 to cancel on the left-hand side, leaving us with just x is equal to 1. So now we have this value here for x, and we want to use it to find a value for y. Well, what we can do is plug this value into this equation here, 4x minus 3y equals 1. The reason we know that's going to work is because when we plug in a value for x, we'll only be left with y, so we'll be able to solve for that variable. So when we do that, we'll get 4 times x, or 4 times 1, minus 3y is equal to 1. We'll get 4 minus 3y equals 1. If we add 3y to both sides, we'll get 4 is equal to 1 plus 3y. Subtracting 1 from both sides, we get 3 equals 3y. And then dividing both sides by 3, we get y is equal to 1. Now, with a value for x and a value for y, we can plug both of them into one of the original equations to find a value for z. So if we plug them into our first equation here, we're going to get x, or 1, plus 2 times y, or 2 times 1, plus z is equal to 4. We'll get 1 plus 2 plus z equals 4, or 3 plus z equals 4. Subtracting 3 from both sides, we get z is equal to 1. So we found the value of z to be 1. Now we have this solution, x equals 1, y equals 1, z equals 1. We can also write it this way as just 1, 1, 1, we can write the solution to this system of equations this way, but we need to check to make sure that this solution also works for these other two equations. Remember that we plugged x and y into our first equation here to find a value for z. So we already know that the solution works for the first equation, and we can go ahead and check that off. But we also need to make sure that it works in these other two equations. So we'll plug all three values in to make sure that we get a true equation. So here for our second equation, we'll call it equation 2, and then this one equation 3. So for equation 2, we'll get 2 times x, or 2 times 1, minus y, or minus 1, minus z, or minus 1 is equal to 0. When we simplify, we'll get 2 minus 1 equals 0. 2 minus 1 is 1. 1 minus 1 is 0, so we get 0 equals 0, and that one checks out. So we know that this also works with the solution that we found. Now we'll test equation 3, and we'll get 2 times x, or 2 times 1, minus 2 times y, or minus 2 times 1, plus z, or plus 1 is equal to 1. When we simplify, we'll get 2 minus 2 plus 1 equals 1. 2 minus 2 is 0. 0 plus 1 is 1. So we get 1 is equal to 1. So our third equation works also. And as a result, we know that the solution 1, 1, 1 is a solution to this system of equations.